Hello friends, hope you all are very well. Today we are going to know very basic concepts of electricity. Electricity is very important chapter for both CBSE and ICSE class 10th boards. So in today's session we are going to know the very basic concept that is related to the electricity. First of all, what is electricity? If you see around you that you can see the bulb is glowing, the appliances, electric appliances that is running, that all are run due to the flow of electricity. So when we are studying physics, actually we are studying the things that is happening around us. So first, let's know what is electricity. Very basic definition of electricity is, what is electricity? Electricity is nothing but it's a flow of charge. Is the study of charge. Flow of charge is something else. Is the study of charge. Electricity means study of charge. Something that is study of charge. We actually in electricity we study that how charge behave in certain condition. Now charge exists in two states. One, when it is at rest. Second, when it is moving. That means it is in motion. So the properties of charge that exist in a rest state that we study, that is called the electrostatics. And the properties of charge when charge started moving, that we study, that is in current electricity. For class 10th, we basically study the properties of moving charge. But before studying the properties of moving charge or the charge at rest, first we have to know what is charge, isn't it? So let's know something about charge. What is charge? Charge is the natural property of body, like the different magnet has the property of attraction and repulsion. Similarly, the charges also have charges is also a natural, like the mass, time, and different. These are the physical quantities they are the fundamental quantities. Similarly, charge is also fundamental quantity. Now, how can you describe the charge? What is actually charge? To know charge better, first we have to go to our standard 9 chemistry classes that we have studied the structure of atom. Definition of charge says, charge can be defined as, it is the flow of electrons. If we go to standard 9 chemistry classes of atomic structure, we can remember the Bohr's atomic model. What was the Bohr's atomic model? Niels Bohr said that inside the before Dalton's theory, and other scientists also concluded that the matter is made of a very tiny particle that is called the atom. Later on, the scientists like the James Chadwick, Goldstein, Rutherford, and Niels Bohr, they have concluded that how the inside the matter the atoms exist, what is the orientation of the atom, and how they present inside the matter. So they further discovered the different types of subatomic particles. I am not explaining this topic in a detailed way that what is the atomic structure. I am just going to explain you what is charge and how it is related to the charge. Atom constitutes basically three particles. One is electron, second is proton, and third is neutron, isn't it? That you have already studied in your standard 9. If we talk about the basic atomic structure, this is called the nucleus, that we all know. Inside the nucleus, two particles exist. One is proton and second is neutron. One is proton and another is neutron. And remaining the third particle, the electron, spins around the nucleus in different concentric circular orbits. Okay, these are called the orbits or the energy level, that you know very well. Means electrons are keep on moving around the nucleus in a concentric circular way. While the discovery of electron and proton took place, that people came to know, in case of electron, in case of proton, the charge over electron is minus 1.6 into 10 minus 19 coulomb, and the charge over proton is 1.6 into 10 minus 19 coulomb. Here you can see the magnitude of the charge carried by the electron and the magnitude of charge carried by the proton, both are same, means the mathematical value of both proton and neutron are equal. And we know that two mathematical value, if equal with opposite sign, they get cancelled out, like minus 4 and plus 4 gives the result is 0. That's why atoms are neutrally charged, means there is no such atom that generates charge itself. Like if you take an example of a copper wire is a conductor, very good conductor, means electric current flow through it very well. But have you seen that the copper wire that is placed at your room starts generating current without connecting to any source? Absolutely not. If you want to generate certain amount of current through it, we have to connect it to a source, either to a battery or to AC source. So that means all the atoms that present in the universe are neutrally charged, means they carry zero charge, because the magnitude over the electron charge carried by the electron and the proton both are same, but they are of opposite nature. So where does the charge, then how charge flow? How we say that a body is charged and how we say that body is uncharged? Because we know that all the matter are made up of these atoms, isn't it? All the matter are made up of these atoms. That means either the body can be charged and uncharged. For that, if I take an example, if I consider the value of here, instead of this complicated value, if I take a very small value, let's assume that electron carries minus 4 coulomb charge and the proton carries plus 4 coulomb charge. Okay, means proton carries plus 4 coulomb charge and electron carries minus 4 coulomb charge. If I somehow increase the values of proton, let it be 5 coulomb, means I added certain number of protons. Now if I take the difference, that is minus 4 and plus 5, that will give you plus 1. That means we can say that body is positively charged. Okay, if I somehow increase the value of electron and the value of proton will remain same, so you can see the difference is minus 1 coulomb. So you can say a body is negatively charged. But the problem is that proton exists inside the nucleus and it is next to impossible to break the nucleus. Only it can be broken in the case of when we do nuclear fusion. And nuclear fusion, you know, that is a very big process we cannot do at home. So how a body can be charged? So only one way that we make a body charged, by positive charge or negative charge, by disturbing the number of electrons. If we disturb the number of electrons, means if we minimize or maximize the values of electron, then we say that a body can be either charged positively or negatively. Let me explain by giving a certain example. Suppose this body has 4 electrons and the electrons have minus 4 coulomb charge and the proton has plus 4 coulomb charge. If I liberate one electron, 1 coulomb electron is liberated. Now the remaining electron is minus 3c and plus 4c. So the difference of charge will be plus 1 coulomb, isn't it? So we can say that body is positively charged. If we add one electron, now we added one electron, now it becomes 5 coulomb, minus 5 coulomb and plus 4 coulomb, and the difference will be minus 1 coulomb. We can say that body is negatively charged. So from here we can say what is charge? Charge is nothing but the flow of electron, very basic definition, because all the matters are made up of very tiny particles. They are called the atoms. We have discussed that how the atoms inside the atom, the electrons, protons, neutrons exist and how they affect the magnitude of charge. So the types of charges are positive charge and negative charge. So from here you can get the definition of charge. What is charge? Charge is the flow of electron, isn't it? Charge is the flow of electron. formula of if a charge is denoted by Q and it is formulated as an E, where N is the number of electrons and E is the charge on it, which is 1.6 10 to the minus 9 coulomb. Q SI unit of charge is SI unit of charge is coulomb. It is denoted by capital C. Okay. So types of charges are there. Two types of charges. One is positive charge. Second is negative charge. Now how can you define positive charge and how can you define negative charge, isn't it? How can you define positive charge? You can here see easily that with this example, when a body was positively charged, when the number of electrons was less than the number of electrons was less than the number of protons, means positively charged body, when a body is electron deficient, that is number of electron is less than number of proton, isn't it? Number of proton means when a body liberates electrons, means it donates the electrons, that body is said to be positively charged. Okay, in general term you can say if you want to donate something, you must have more than that you have, then you can donate. So a donor type, in previous class 8 there was chapter of electrolysis where you have discussed the types of ions, cations and anions. What was the cations and what was the anions? A donor type that donates, they are called the cations, and that accepts the charges, they are called the anions. That to discuss later. Negatively charged body. A body is said to be negatively charged body when a body is electron efficient, that is number of electron is more than number of proton, isn't it? That's why it carries a negative charge, means it is in depth, that's why it is a negative charge. So simple definition of electron charge is that the flow of electron is called charge. Charge is denoted by Q, capital Q, where Q is equal to N into E, where N is the number of electrons and E is the charge over a single electron. Types of charges are there: positive charge and the negative charge. Positive charge, when we can say a body is positively charged when the number of electrons is less than the number of protons, means electrons are liberated. Okay, electrons are liberated, that's why that is positively charged. Similarly, a body is said to be negatively charged when the electrons are gained, means somehow the more electrons are added, that's why it is called a negatively charged. Now the next topic is quantization of charge. What is the meaning of the word quantization? Quantize means to give something a mathematical value, isn't it? If you want to quantize something, you have to give it a mathematical value. So let's see how charge is quantized. Heading should be quantization of charge. Quantization of charge or electric charge. What was the formula of charge? Q is equal to NE. Let's assume a condition. Let's take an assumption that Q is equal to 1 coulomb. We have considered a situation where the 1 coulomb of charge is flowing, then E is 1.6 into 10 to the minus 19 coulomb, unless we have to calculate that how many numbers of electrons are flowing through that circuit. Let's say Q is equal to N into E. Q is 1 coulomb, and that we need to calculate, and value of E is 1.6 into 10 to the minus 19 coulomb. Coulomb cancel out. N is equal to 1 by 1.6 into 10 to the minus 19 coulomb. 1 by 1.6 10 to the power 19. We can write this thing this way. Simply we can write this. Further, if we solve, we get 6.25. 0 cancel out. Then cancel out this value. One value will be decreased. That will be 10 to the power 18. So you can see when 1 coulomb of charge is flowing, in that case the number of electron that is passing through, that is called the 6.25 into 10 to the power 18 coulomb. That's why I said that when charge is flowing, there is abundance of electrons. That means enormous number of electrons are flowing through the circuit. That was very basic numerical and the first numerical of this chapter, that how charge is quantized. So you can simply see the Q is equal to Ne, which is the formula of charge, and the current. We assumed a condition that in that case that the 1 coulomb of charge is flowing through there, and the charge for 1 electron is 1.6 into 10 to the minus 19 coulomb, and the number of electrons that you need to calculate, that is 6.25 into 10 to the power 18 coulomb, 18 electrons. So that is the quantization of charge. Now the next topic is electric current. What is electric current? Hope you have noted it down. Electric current, very interesting chapter, very interesting topic actually. Electric current. Charge we have studied. Now we study the electric current. Important. It is the flow of charge. It is the flow of charge. It is the rate of flow of charge. It is the flow of charge per unit time. So it is denoted by capital I. Its SI unit is ampere, which is denoted by capital A. Okay. The definition of charge is, a definition of current is, it is the flow of charge per unit time. That means current can be written in this way: I is equal to Q by T. Very important formula. It will be used further, where I is the current, Q is the charge, and T is the time. So 1 ampere can be defined as coulomb per second. That means 1 ampere is equal to coulomb per second. That means we can say when 1 coulomb of charge is flowing per unit second is called that 1 ampere of current is flowing through that circuit. Okay, the definition of current is what? Current is the flow of charge per unit time. It is denoted by capital I, and the SI unit of current is ampere. Take, and the formula is I is equal to Q by T, where I is the current and Q is the charge over it, and T is the time period. That's it. Now, most important point: what is the direction of flow of current in a circuit? That we know in a circuit, in any circuit. Suppose you consider a circuit, just to make a circuit. Okay, just to make a circuit. This is a positive terminal, this is a negative terminal, isn't it? We know if I switch on this circuit, that means current will start flowing in this way from the positive to the negative terminal. But actually just I have discussed that what is a charge. Charge is the flow of electron. Electron is what kind of particle? It is a negatively charged particle. And what is the definition of current? It is the flow of charge. Ultimately in a circuit, electrons are running, electrons are flowing. That means how could it possible that there is an existence of a positively charged particle? If we consider the direction of current, that is current starts from the positive terminal and terminates to the negative terminal, and in a circuit electrons are flowing only, and it is a negatively charged particle. Initially, if we talk about the direction of conventional current, initially the scientists considered an imaginary positive charge. He considered there is a charge, imaginary charge, which is positively charged. But later on, as the electron, proton and other things were discovered, the people and scientists came to know that there is no such existence of a positively charged particle. All the particles that actually in a circuit that is flowing is an electron, which is a negatively charged particle. But till that date, many mathematical and the physical calculations were done, many researches were done. So the scientists avoid to disturbing the conventional theories. So the scientists considered the direction of, keeping this point in your mind, direction of conventional current is from positive to negative terminal, positive to the negative terminal, positive to the negative terminal. Just keep this thing in mind. Whenever you draw a circuit, to always keep one thing in mind, that the current start flowing from the positive terminal and it terminates to the negative terminal. Now let's come to the practical direction of the current, that is the direction of electrons. So before knowing this, that you know that any kind of energy flows from the higher potential to the lower potential. For say, if you have a hot body something, if you put that hot body near to the cold body, after some time you will see that the cold body is also getting hot. How it happens? Because that hot body transmits its energy to the cold body, isn't it? So same thing is applicable to each and every entity of physics, that the energy always transmits from the higher potential to the lower potential. So in case of battery, in case of source of energy, the negative terminal has more electron. The negative terminal has more electron. So the electron starts traveling from the negative terminal and terminates to the positive terminal, isn't it? Which is less number of electron. That means there is no such positive charge exist. Only two terminals exist. One has more number of electrons than the others. So the other part which has more number of electrons, it transmits its electron to the other part. That's it. That is the. So if anyone asks you the direction of electron, is from negative terminal to the positive. So this thing, we hope this thing will keep in your mind. You will keep in your mind, like the electric current, it is the flow of charge per unit time. It is denoted by I. It is SI unit is ampere. The formula of current is I is equal to Q by T, where I is the current, Q is the charge, and T is the time period. Now direction of the conventional current, it starts from the positive terminal to the negative terminal. That you need to make a diagram. Whenever you make the diagram, and when the resistance and other topics will come, you will need to draw diagrams. So whenever you draw diagrams, you need to mention the direction of the current. You just keep the one thing in mind, that in conventional current, the direction of current, it starts from the positive terminal and terminal to the negative terminal. Similarly, the direction of electron is from the negative to the positive terminal. So this much for today's session. In the next video, we will be discussing few numericals of this chapter, and we will continue with the electric potential and potential difference. Thank you so much.